SwayamPrabha. Digital India. Educated India.
Hello, welcome to Basics of Noise and its Measurement. This week we are having the discussions on discrete Fourier transform, and in the last class we had introduced this concept of DFT, its relationship, and what we are going to do now is continue with the example which we discussed in the last class and actually use the data points which we generated in the last class to compute the discrete Fourier transform of the function which was described. So that's what we will do. We'll continue the discussion on this discrete Fourier transform. These are the points which we have generated, and using these values, so this is x0, this is x1, so these individual points are values of xn. So this is x0, this is x1, x2, x3, x4, so on and so forth. And as I go on for 3 seconds, this is my x23. I have a total of 24 points, but because my numbering starts from 0, so I end up with x23. And remember here that I am not completing the cycle, because I have the duration of 3 seconds and I have done 24 points, 8 points per second. So I have to generate 24 points. The last point, if I completed this cycle, it would be the 25th point, but here I am just doing 24 points. So it's important to understand that. So this is the thing. Another thing I wanted to mention is that in this relation xk equals xn exponent to this entire term, there is no explicit mention of time. The information about time is embedded in the frequency, duration of time and sampling frequency. But in this formula, there is no explicit mention of time. The values of x are mentioned, which is xn, but the values of time are not explicitly mentioned. So when we do a Fourier transform, all we require is a series of numbers, and then how they are related to time information is actually dependent on these parameters, fs, duration of time and so on and so forth. So this is again important to understand. So what we will do is we will compute a couple of values. So for k is equal to 0, x0, so what are we going to compute? This capital X implies that it is the Fourier domain representation of the signal. So we will be calculating x0, x1, x2, it will be x23. So this is equal to summation of n equals 0 to 23 xn cosine of 2 pi, and the value of k when k is equal to 0, I mean value of k is 0, so 2 pi kn, so 2 pi times 0 times n over n minus I sine 2 pi times 0 times n over n. So this is what we are going to sum on. Okay. So we have put the value of k as 0. Okay. Here let us do k is equal to 2. So that will give us the value of x2, and that will be equal to summation n equals 0 to 23 x n cosine of 2 pi, and the value of k is 2 n over capital N minus I sine 2 pi 2 times n over capital N. So, I can calculate all the values of x0, x1, x2 and so on and so forth, and I will just still write down one more number. So, this is for k equals 23. If I plug in the value of k equals 23, I get x23, and that is equal to n equals 0 to 23 x n cosine of 2 pi times 23 times n over n minus I sine 2 pi times 23 times n over n. So, that is the thing. Okay. So, I can calculate these values. I have a formula, it is pretty straightforward. I can do these calculations, and what I will show you is the actual values for the function. Okay. So, this is the value of n. So, n is equal to 0, 1, 2 and it goes on till 23. Then my next column is for time t. So, t is 0 in the beginning. Then the next step of t is 1 over 8th, because the sampling frequency was 8 hertz. The next value of time is 0.25 and so on and so forth. So, I come up to 2.875. Okay. So, yeah. Then, so I am sampling this for a period of 2.85 seconds, and because my sampling frequency is 8, I will get 24 points. Okay. So, this is important to understand. If I sampled it for 3 seconds, so there was a little error because I said that I will sample it for 3 seconds, it should have been 2.875 seconds. So, if I sample it for 3 seconds, it would be n equals 25, capital N would be 25. So, my intention was to generate 24 points, not 25 points. My intention was to generate 24 points. Then the next column is for ft, and this is the value of that function, which is 2 sine times 2 pi f times time. Okay. And then these rows correspond to the value of different values of k, and here I have included information only till k equals 4, because I could not go on beyond this screen, but this would continue to 5, 6, 7 till 23. Okay. So, the first column corresponding to k is equal to 0 is a specific value for the real portion of that Fourier transform, and when I have, and so this number corresponds to the real portion when n equals 0. This corresponds to the real portion of the component when k is equal to 0 and n is equal to 1. Here k is equal to 0, n is equal to 2. Here k is equal to 0, n is equal to 3, and so on and so forth. So, these are all the real components. Similarly, these are all the imaginary components. And what I have done here is I have added them up. So, this is my this FFT. This is the sum of those real things, sum of all the cosine terms. This is sum of all the sine terms, and this is the magnitude, which is this square plus this square, and this is the square root of that. Okay. So, this is the value of magnitude of x k, and if I have to look at its imaginary and real portions, x k when k is equal to 0 is 0 plus 0 I. Here x k, so this is, these two columns are when k is equal to 1. So, this is when x, so k is equal to 1, then this is the value of xk is 0 plus minus 7 into 10 to the power minus 16 times I, and the overall magnitude is 7e minus 16, and so on and so forth. So now look at 3. So practically all the components are coming out to be 0, right? This is e minus 16 is 0, or pretty much close to 0, but you come to column 3 and what you will see is that the real component is 0, the imaginary component is minus 24. Okay. So in this case, the Fourier component corresponding to k equals 3. Now 3 is not same as the frequency. Frequency was 1 hertz. This is 3. So this is not equal to frequency. But for Fourier component when k was 3, the value of xk is 0 minus 24i, and the magnitude of it is 24. And then for the fourth component when x4, it is again 0 plus 0. And we can keep on doing this mathematics till we get x is equal to xk when k is equal to 23 in our case. So we get all these values. So then the question is, what do we do with these numbers, right? Because this 24 was not the amplitude of anything, and neither 3 was the frequency. So we have to figure out how to map this information into the real thing. So the first thing we will do is we will learn how to convert the values of xk into specific amplitudes of specific frequencies, you know, because what we saw that amplitudes in this case were pretty much 0, in one case it was 23, and all other places, at least what we saw, it was 0. So we have to somehow convert that into something real. So, okay. What these frequencies are, we will not talk right now, we will do that later, but right now we will just learn how to convert this xk into frequency related amplitudes. Okay. So we will very quickly draw this spectrum, or we will plot the values of xk. Okay. So we will start from 0 and we will end with 23. Okay. So that's 22, 21, 20, 19, and here it is 1, 2, 3, and so on and so forth. So what we saw was that at k is equal to 0, the value was 0. So it was 0. At k is equal to 1, value was still 0. At k, so this is, let us say, my vertical axis, and k is equal to 2, it was still 0. At k is equal to 3, we found that the value was 24. So this was 24. And then you keep on computing, you will find that there were lots of zeros, and at all places it was 0. But till you come to 21, and then this is 22, this is 20. So at 19 also it was 0, so it was 0 here, 0 here, 0 here, 0, 1, 2, but 0, 1, 2, and at 3 it was here, it was 0 at 19, it was 0 at 20, but at 21 it was again the magnitude I am talking was 24. Okay. And then at 22 it was 0, and then also 22, 3 it was 0. If you did the computation, this is what you will get. Okay. And you had a total of 24 points. So this is how you calculate the frequencies. First thing is, ignore all values of xk when k is greater than n over 2 minus 1. So, in this case what does that mean? You take only the first 12 points, right? You take only the first 12 points. N by 2 is what? N is 24, right? N is 24. N by 2 is 12. 12 minus 1 is 11. So, you ignore all n is equal, this k is equal to 12, 13. So, you have ignored 12 points, right? So, you ignore all those. So, you take basically the first 12 points or take first half points only. This is in plain English. You take only first half points, okay? All others you ignore, you do not have to worry about those. Second, amplitude of each actual frequency. We have not figured out how to calculate actual frequency yet. Actual frequency, each actual frequency. See, this k is associated with some frequency number, but we do not know what is the value of that number, okay? K is equal to 0 means it is associated with some frequency. K is equal to 1, it is associated with some. We do not know the values of these frequencies, but xk will tell us something about the amplitude, but not the actual amplitude. So, amplitude of each actual frequency is equal to xk divided by n times 2. Because you ignored the other half, you have included there, you will always find that when you do this analysis, this whole figure will be symmetric. Okay, and you ignore the second half, you take only the first half. To account for the other half, you multiply it by 2. Why is all this happening? We will not discuss in this particular lecture, but you multiply it by 2 and you divide it by the total number of points, which was in this case 24. So, what does that mean? So, this is the indicated frequency, but actual frequency. So, x3 actual is equal to 2 into 24 by 24 is equal to 2. Okay. Now, when we go back to our original sine function, its amplitude was 2. If you remember, it was 2 sine times 2 pi ft. So, now we have been, and there was no other frequency in the signal, right? There was only one frequency. So, all other frequencies are coming to be 0. There is only one frequency, and that is its amplitude is 2. What is its frequency? Right now, from this analysis, we have not figured that out. So, that is something we will discuss in the next lecture. Thank you.